Hello, welcome to a creative YouTube channel. So today is a session 4 and we are going to learn very interesting topic called the clock memory. Okay, so clock memory is very useful as we already know about the clock word. Clock word means clock is a signal will change its state at predefined interval with signal and no signal. 1 by 1 ratio. Okay, so it's a periodical signal will change its state periodically. Okay, so first of all we will access the help of TI portal. We will search for the what is the clock memory bit. So by pressing F1 from your keypad you can access the TI portal help. Okay, so I already open here. This is my using clock memory. Okay, you can search so many topics here by search for clock memory or whatever you want to search about it. Okay, so today we are going to discuss about using clock memory. So we have already searched topic clock memory. So what is clock memory? A clock memory is a bit memory that changes its binary status. So binary status means 0, 1 periodically. The pulse no pulse ratio of 1 by 1. Okay, so you already got the idea. Again we will go to the paint and we'll see. See here you can see this is the signal value axis and the time axis. Okay, my signal is going from 0 to 1 and then again 1 to 0 and again 0 to 1. So you can see the on interval and the off interval both are same. Okay, that is clock memory. Okay, the interval time between on and off will be same. And this is one cycle which is starting from the 0 to interval 1 and again going back to 0. It's called the one cycle occurred in some predefined time. So number of cycle occurred in 1 second, called the frequency. So number of cycle means more cycle occurred in 1 second, so frequency will be high and time required is less, and more time required to complete one cycle, it's called the less frequency and time is more. So time is inversely proportional to frequency, you can say. So this is our equation called time and frequency relation equation. Okay, again going back to clock memory, the second statement say you decide which memory byte of CPU will become the clock memory byte when assigning the clock memory parameter. So before understanding this, we should understand the memory byte area. So previously we already discussed about PII area and PIQ area, process image input and process image output, which is a memory to store the input and to store the output status in the CPU. Now CPU having one another memory which is called the uh, byte memory, or you can say the memory byte or memory bit area. So let me take one example. It's the same page which is used for the bit memory. Okay, you can say also the bit memory. So again bit memory is divided in the byte. Okay, let me draw the 2-3 line which is act as my byte. This is the imaginary drawing CPU having this type of storage area, but we are taking reference to understand what is the use of bit memory. So this is my byte. Sorry. Okay, I'm just writing byte 0, byte 1, byte 2, and so on. Okay, up to n. So this is my up to n. Okay, so this is n. So S7 1200 having total 8192 byte bit memory, which memory you can use for like storing of the data and to doing the internal calculation of your logic. This memory is not a retentive type. Okay, you can retentive some part of this memory with the help of siemens. It is a different between CPU to CPU, but keep in mind that this is not a retentive type of memory. Okay, you can use this memory for internal calculation purpose, storing of the some temporary information. Okay, and you can use for the interlock purpose. We will see in the example session what is the actual use of bit memory and how we can utilize this very useful memory. Okay, now again the byte area will divided in the bit. Okay, there are total how many bits in byte? There are total 8. 3, 4, 5, 6, 7, 8. 7, 8. Okay, so there are total 8 bits in one byte. So again, as you already seen that input address starting from the I, then byte address dot bit address. Output address starting from the Q, byte address and bit address. So same memory, bit memory address will start from the M and byte address and dot bit address and M8191 dot say 1. Why? Because we have a 8.92 byte of memory. We'll start from the 0, so next address will be n minus 1, called the 8192 minus 1, it's called the 8191.7. So this is memory area you can use for as a scratch pad, and you can store the internal information. Okay, so again come back to TIA portal help. You can use clock memory, for example, to activate the flashing indicator. So we can use this type of clock signal to give some alarm function, or to flash some lamp, to flash output. We want some periodical signal, for that we can use this type of clock memory. The actual application we will see in the upcoming session for the PLC example practical application. So today just we will understand what is the clock memory and how we can utilize and how we can activate this clock memory in our S7-1200 CPU. Okay, so this is predefined format given by the Siemens. Okay, the available frequency. This is the available frequency in our S7-1200 PLC. So first row is bit of the clock memory. Okay, so there are total, as you already seen, you can assign any byte of clock memory as a clock memory, any byte of bit memory as a clock memory. So there, in every byte there are 8 bits, so they have mentioned 7 bit, 6 bit, 5 bit, 4 bit, 3 bit, 2, 1, 0. Okay, so each bit will produce this much hertz signal. So bit 0 of byte will produce 10 hertz signal, bit 1 will produce 5 hertz signal, and proportionally time period will be 0.2. Okay, because 1 by 5 is 0.2 second, because time is inversely proportional to frequency, and so on. 0 will give you the higher frequency, but time will be less. So if you want fast switching, you will use bit 0 of byte. Like if you are assigning the 0 byte as a clock memory, then M0.0 will be your 0.1 second signal, which is very fast. And same, if you are using 7 number bit, you will get the 2-second period signal. So every 2 seconds you will get 1 0 1 0 1 0. Okay, will be 0.5 signal, because here frequency is less and time will be 5. And there is some important note given: clock memory run asynchronously to the CPU cycle. So as already we discussed in the previous session, like what is the CPU cycle? CPU cycle is, it will scan the input, physical input, okay, and according to your program it will write the output. This time required to read the input, execute the program and write the output, it's called the CPU cycle. So clock memory run asynchronously to the CPU cycle. Now let's say example, your CPU cycle is 500 millisecond. Okay, your logic is very big and your CPU cycle is 500 millisecond, and you are generating the pulse which having 200 millisecond time period. Okay, so if you wait for the CPU cycle, your clock memory will not execute, but your clock memory run asynchronously to the CPU cycle. It will don't care about CPU cycle, whether it's 500 millisecond, whether it is a 1 millisecond, whether it is a 1 second, that doesn't matter. Your clock memory will run at exact 200 millisecond or whatever the signal you have chosen. Okay, it won't depend on the clock CPU cycle. The status of the clock memory can change several times during the long cycle. Okay, so, we already discussed, like if your CPU cycle is very long, then clock memory can change several times during the fixed long one CPU cycle. Okay, because if you're having less period of your clock memory, then obviously clock memory will change its state several times if your CPU cycle time is higher than your clock memory. The selected memory byte cannot be used for the internal storage of the data. Okay, so if you are using byte 0 for clock memory, then you should not use that byte for the some internal calculation or intermediate data storage. Okay, you won't consider that byte for data calculation or data storage. That particular byte will only be reserved for clock memory signal. So keep in mind. Okay, so now again come back to our TIA portal software. Now we'll see how to activate this clock memory in our CPU in the real-time application. So for that we will go to the device and network. Okay, device and network window, and there is our CPU. Double click on it, it will open as a device view. Okay, now go to CPU property. There is a property option in inspector window, and here you can see just look for the clock and system memory. So this is our system and clock memory. We'll see the system memory later on, as today we will discuss about the clock memory. So we won't enable the signal. Just look for the clock memory bit and enable the use of clock memory. So if you want to use this clock memory, then you have to check mark this enable. Now as you can see, you can decide any byte between 0 to 819. This is our memory bit area. So you can use any byte for the clock memory. So by default it will select 0, and we won't change, we'll leave it as 0, but you can change anything here between 0 to 819. Okay, so here you also get the table like I'm 0.0. If you are choosing 0, if I'm choosing 1, then 1.0 will act as a 10 Hz signal, 1.1 act as a 5 Hz signal, 1.2 as a 2.5 Hz signal. Okay, so I want only 0. Okay, so now your 10 Hz signal will be very fast and your 0.7 signal will be very slow. Now we will use all signal from 0.0 and 0.7 and we will see what is the difference. Now keep in mind, when you will change in the CPU property, you must have to download the hardware. Compulsory, not software. You have to download the hardware. Then and then a clock memory will come into picture. Okay. So for that, again we'll start our simulation to download our project. Okay, simulator has been started and project is going to be download. Loading not performed because the conditions are not met. There is some error. What is the error? We don't know. Again we'll start downloading. Okay, there may be some issue with software or whatever, we don't know, but there is no error. Okay, now okay, fine. Now the program is going to download, and again we have to select start our module, means to run CPU. Okay, we'll finish it. Okay, now project has been loaded and CPU is in run mode, and again we'll download our only hardware part. Okay, so hardware has been downloaded. You can see the hardware configuration, the software has been loaded, the hardware configuration has been loaded. Okay, so it means your project has been downloaded and hardware also downloaded. Your property has been activated. Now we'll start one small program. This is my I0.0. Okay, now previously we are using tag table to create our tag, but you can rename tag by right click on and rename tag. You can say this is the activate Okay, so we are going to force our I 0.0 so we can activate this logic. I will enter here 1. Okay, and you can go online, CPU is okay, and I will force the signal, force all. Now the I 0.0 has been forced and you already got the signal here, and we will monitor our logic as well as the signal. Okay, and here you can see, okay, the every outputs having some different interval to switching their status. See, this Q0.0 is very fast, switching its status very rapidly. Okay, because it's having 10 hertz clock signal, means higher the frequency, less the time. Okay, and you can see Q0.0, it's changing its state at every 2 seconds because it's having less frequency, around 0.5 hertz. Okay, so it require more time to change its state, but the off time and on time both are equal. Okay, so this is how we can use this signal for alarm indication or to execute some periodical task. Okay, this type of application in which we can use this clock memory. We'll see this use of clock memory in some industrial task. Okay, but before that we have to learn some basic instructions, and we will use all this instruction to design our industrial application. Okay, so for the today's session, this is all about clock memory. So thank you for watching, and please share this channel, subscribe so we'll get motivated, and I can design some more course and some more advanced video, and we have to learn a lot of things like SCADA, some IoTs. Okay, so just give your support and my effort, we can make this universe very better. Okay, so thank you for watching. Like, share and subscribe. Thank you.